What if I told you a star could survive while orbiting the most terrifying object in the universe, a black hole? It sounds impossible, but it's real. Imagine a brilliant star shining brightly, trapped forever in the invisible grip of a cosmic monster that swallows even light itself. It sounds impossible, almost like science fiction, but the astonishing truth is that astronomers have discovered real stars doing exactly that. These extraordinary celestial bodies are known as black hole stars, and they are helping scientists unlock some of the greatest mysteries of the universe. Today, we're diving deep into this incredible phenomenon to answer one fascinating question: can a star really orbit a black hole? The answer may completely change the way you think about space. A black hole is not a giant vacuum cleaner that randomly sucks everything nearby. Instead, it is an object with gravity so incredibly powerful that once anything crosses a boundary called the event horizon, escape becomes impossible, even for light. Black holes are born when extremely massive stars collapse under their own gravity after exhausting their nuclear fuel. During this collapse, the star's core becomes unimaginably dense, compressing several times the mass of our Sun into a region only a few kilometers wide. Although black holes themselves are invisible, their enormous gravitational pull reveals their presence by affecting nearby stars, gas, and even the fabric of space-time. So, can a star orbit a black hole? Surprisingly, yes. In fact, stars can orbit black holes in much the same way that Earth orbits the Sun. Gravity doesn't automatically pull an object straight inward. If an object has enough sideways motion, gravity bends its path into an orbit instead of causing an immediate collision. Think of it like swinging a ball tight to a string. The string constantly pulls the ball inward, but the ball keeps moving around you because of its speed. Similarly, a star moving fast enough can remain in a stable orbit around the black hole for millions or even billions of years. One of the most spectacular examples exists at the very center of our own Milky Way galaxy. There lies a supermassive black hole called Sagittarius A star, containing roughly 4 million times the mass of our Sun. For decades, astronomers have carefully tracked several nearby stars racing around it at incredible speeds. Among them, the most famous is S2, a star that completes one orbit every 16 years. At its closest approach, S2 travels at nearly 3% of the speed of light, while surviving the tremendous gravitational forces. Observing this remarkable star has allowed scientists to test Albert Einstein's theory of general relativity with extraordinary precision, confirming predictions about how gravity bends space and even affects the passage of time. However, not every star is fortunate enough to maintain a safe orbit. If a star drifts too close, the black hole's gravity becomes dramatically stronger on the side nearest the black hole than on the opposite side. These unequal gravitational forces are called tidal forces, and they can stretch the star like spaghetti, a dramatic process astronomers call spaghettification. Eventually, the star may be completely torn apart in a violent event known as a Tidal Disruption Event, or TDE. As the shredded stellar material spirals inward, it forms a blazing disk of superheated gas called an accretion disk, producing enormous bursts of X-rays, ultraviolet light, and other high-energy radiation visible across millions of light-years. Not all black holes are supermassive. Some are much smaller, known as stellar mass black holes, typically containing between 5 and 100 times the mass of our Sun. Surprisingly, these smaller black holes can also have companion stars. In these systems, the companion star often loses gas to the black hole through gravity. The stolen gas forms an intensely hot accretion disk before disappearing beyond the event horizon. Although the black hole remains invisible, the glowing disk shines so brightly that astronomers can detect it with space telescopes. One famous example is Cygnus X1, one of the first confirmed black holes ever discovered. Here, a massive blue star orbits an invisible black hole while continuously feeding it. Scientists also believe that black holes and stars sometimes evolve together in even stranger ways. In dense star clusters, gravitational interactions can flank stars into new orbits, create binary systems, or even eject stars completely from their galaxies.
Some stars orbit so closely that they gradually spiral inward over millions of years, while others remain remarkably stable. These interactions help astronomers understand how galaxies grow, how black holes gain mass, and how some of the universe's most energetic explosions occur. One fascinating question often asked is whether a planet could orbit a star that itself orbits a black hole. According to current physics, the answer is theoretically yes. If the star's orbit around the black hole is stable and far enough away to avoid destructive tidal forces, planets could potentially remain in orbit around the star. However, life on such planets would face extraordinary challenges. Powerful radiation from nearby accretion disks, intense gravitational effects, and unpredictable cosmic environments would make survival extremely difficult. Nevertheless, the laws of physics do not completely rule out such bizarre planetary systems. Black holes also provide one of the greatest laboratories for studying gravity itself. Around these cosmic giants, time behaves differently than it does on Earth. According to Einstein's theory, clocks closer to a massive object tick more slowly than clocks farther away. This phenomenon, known as gravitational time dilation, has been confirmed through observations of stars orbiting Sagittarius A star. If a spacecraft could safely orbit close to a black hole, time for its passengers would pass more slowly compared to people far away. Although this idea has inspired countless science fiction movies, it is rooted in real physics. Modern observatories continue to revolutionize our understanding of black holes. The Event Horizon Telescope produced humanity's first direct images of black holes, while gravitational wave observatories such as LIGO detect ripples in space-time created when black holes collide. Meanwhile, advanced telescopes keep discovering new stars orbiting black holes across our galaxy and beyond. Every new observation reveals another piece of the puzzle, bringing us closer to understanding these mysterious objects that once seemed impossible to study. So, can a star orbit a black hole? Absolutely. In fact, many stars already do. Some peacefully circle these invisible giants for millions of years, while others meet spectacular and violent ends when they wander too close. These remarkable systems prove that black holes are not merely cosmic destroyers. They are also architects of galaxies, laboratories of extreme physics, and keys to understanding the deepest laws of the universe. The next time you look up at the night sky, remember that somewhere among those distant stars, one may be endlessly circling a black hole, dancing on the edge of the impossible. And perhaps, hidden in that cosmic dance, lies the next great discovery that will transform our understanding of the universe forever.